right, so as far as this test is concerned, this is your collaborative test. You get one. Remember I told you at the beginning of the semester, you'll have 6 tests and then your final, well, 7 tests and then your final exam. And so one of those tests is your drop grade, so you do still have a drop grade if you haven't used yours already. And then this test, everybody gets a collaborative test, and so this is our collaborative test. Now, you can look at this test as a take-home test, or you can look at this test as a in-class group test. That's completely and totally up to you. However you want to do your collaborative test is completely and totally up to you. But I wanted to go ahead and put this in your hand so that as we go through the material, you'll have an opportunity to work these in class. So, for example, numbers 1, 2, 3, 5, 9, and that's it. Those numbers that I just called out, we covered that material last week. So if you remember anything that we did last week, or if you want to look in your notes from last week, you should already be able to do those problems. Okay. So again, 1, 2, 3, 5, and 9. Those you should already be able to do based on the notes that we did last week. So what I'm going to do this afternoon is I'm going to hopefully finish chapter 10, and as we go through this, like I said, I'll make reference to your collaborative tests, and you can work on those in class if you want to, or if you just want to take them home. Again, that's your choice also. This test is due, Lord willing, if we're here, because the weather's crazy, Monday, next week, at 3:45. Okay? This test is due next week, Monday, during class, Lord willing, 3:45. No later than 3:45. So if you're sick, you need to send it with somebody, or you need to scan it and email it to me. I will not take a late collaborative test. There's no excuse for a late collaborative test. Okay? So next week when you come into class, I will give you until 3:45 to work on this material. If I have not covered everything, then I'll finish covering it, and then I'll extend your time a little bit. But my hope is by 3:45, this test will be back in my hand. We'll be done with Chapter 10, and we'll move on to Chapter 11. So we'll finish class next week with Chapter 11. Any questions about that? All right, so make sure you understand when this is due. No late tests will be taken. All right. So, logarithms. And again, this is where we're going to go, talking about logarithms. How many of you have dealt with logs before? Either the LOG or the LNs. So this should be a review for most of you. When you talk about a logarithm, the reason it's in Chapter 10 is because logs and exponentials go hand in hand. They're basically kind of sort of inverses of each other. So look at this. If you ask a question, how many 2's do we need to multiply in order to get 8? You would tell me what? 3. 2 times 2 times 2 is going to give you 8. So how many 2's do we need in order to multiply in order to get 8? And the answer is 3. So we need to multiply 3 of the 2's to get 8. This is a logarithm. This is a logarithm. So the logarithm is 3, because 3 is the answer to your question. And that's what you're asking. When it says find the log, it's asking you this exact question. So to write the number of 2's we need to multiply to get 8 is 3. Is like this. You're going to do log base 2, because that's the base that we're using for your exponent, because you know 2 cubed would be 8, so 2 is your base. So 2 is the base of our log, because that's the number in question. And we're trying to get 8. So log base 2 of 8. How many 2's do I need in order to get 8? And that's all that a logarithm is. How many 2's do I need in order to get 8? And the answer is 3. That's what a log is. Now, I can replace any of these, the 2, the 8, or the 3, with an x. And that's where the fun comes into play. You've got to figure out what x is going to be. All right? And so that's what we're doing. So I wanted to give you a general idea of what a log was. And so this is what I need you to remember. Log base b of r equals t is equivalent to b to the t is equal to r. So this, you're going to learn, you're going to know, hopefully, how to go from log to exponential and from exponential to log. And I want you to be able to do that. And all you're doing is replacing or rewriting a logarithm as exponential form. So, for example, you would say 2 to the third power is 8 using that other one. Okay? So, for the first one, write in logarithmic form. In other words, we're going from exponential to logarithmic. So, you are going to have the word or the abbreviation log. And your base is going to be 2 because it's the base of my exponent. If it's the base of your power, then it's going to be the base of your log. So we have log base 2 of 64 is equal to 6. So again, the question is, how many 2's do I need in order to get 64? And the answer is 6. So 2 to the 6th power is 64. So again, it's just rearranging what you already know, what you already have. So this one, same thing. Your base is going to be 3. So you have log base 3 of 1 over 81, and it's a fraction, and anytime you see a fraction, you know that you're looking at a negative exponent, or anytime you see a negative exponent, you know you're looking at a fraction. Okay, so negative exponents, fractions, but it doesn't change anything. 3 is your base, so it's saying how many 3's do we need in order to get 1 over 81? Well, with it being a fraction, we know our exponent has to be negative, so it's going to be to the negative 4 power. Okay, so let's go the other way. What if I ask you to write the log in exponential form? Same thing. Your log base 2, so your base is going to be 2. Log base 2 of 8, 2 to the 8th power, is 256. And that should make sense because you can't say 2 to the 256 is equal to 8. That's erroneous. That's crazy. Okay? So if you have something, just pay attention to what you're writing. It makes common sense, basically. Also, you're like, okay, so which one's my base? So do I do 8 squared is equal to 256? You know that's not right. 8 squared is what? 64. So you can't do that either. So really and truly, it only makes sense to write these one way. So 2 to the 8th power is 256. So the one on the right, your base is 5. And so if we raise 5 to the negative 3 power, when you see a negative exponent, you know that you're looking at a fraction, right? 5 to the negative 3 power is the same as 1 over 125. So again, I need you to be able to go from log to exponential and from exponential log in order to, we're leading up to solving equations, and you're going to have to do this when we start solving these equations, all right? So make sure you can do both of these. So as far as your collaborative test is concerned, let's see. I think I have one on here that's straightforward. Number 6, you can do this. Number 6, number 7, we'll work some problems like these, but look at number 11. That's straightforward. It says write 2 to the negative 5 power is equal to 1 over 32. We just did one like that. That's just like this one right here. 3 to the negative 4 is equal to 1 over 81. We just did that. So number 11, you should be able to do at this point. If you want to go ahead and try it, you can. Okay, so how do you evaluate a logarithm? To evaluate a logarithm, you're going to change it to exponential form, and then you're just going to use your calculator. So we're going to use the property that we learned last week. Remember, if you have like bases and your variable is in the power, if you have like bases, you can set your powers equal to each other and solve. We learned that last week. That was 6.1. That was 10.1. So for this one, I can turn this into the equation. If it says evaluate each logarithm, it's going to say evaluate the log. I can say that this is equal to x, because that's what we don't know. We don't know what log base 2 of 16 is. So it's equal to x, or it's equal to whatever you want it to be. Change it to exponential. Your base is 2, and this is asking how many 2's do I need in order to get 16? That's the question that we did a while ago when we went to that website. How many 2's do I need in order to get 16? So in other words, 2 to the what power is equal to 16? And you can answer that off the top of your head. Most of you can think about that. But the way we did it in 10.1 is we changed our bases to be the same. So basically you're just asking yourself to the what power, and it's going to be 4, so x is equal to 4. Alright, so the same thing in the middle. How many 3's does it take in order to get 81? Like bases. And so again, you get x is equal to 4. Now, the one on the right, the far right, that one's not so easy. We're going to have 3. Again, you can set it equal to x. 3 to the what power is going to give you the 4th root of 27. The 4th root of 27. Well, I'm covering this in Math 100 right now. So those of you who came through Math 100, I know you learned how to do this. You may have forgotten, but in order to use the property that we learned in 10.1, we need to turn this radical to exponential form. So to change the 4th root of 27 to exponential form, it's going to be 27 to the 1/4 power. Do you remember that? Power over index. Remember, this is 27 to the 1st power, and so 27 is your base, and you have your power over your index, so it's going to turn it into 27 to the 1/4 power. Now we're going to use what we did in 10.1 last week, so we're going to do the change of base, so we're going to have 3. 27 is the same as 3 to the 3rd power to the 1/4. So you're going to have 3 to the x is equal to 3 to the 3/4, and so x is equal to 3/4. So again, that's a mixture of Math 100 and what we did last week. Changing your radical to exponential, that's Math 100 stuff. If you need a refresher on that, that's Chapter 5. And then power to a power, that's Chapter 3. That's Math 100 as well. And then this is the only thing that's new. Alright, so where is that? On your test. Probably on the back. Number 20. You don't really know how to do that one just yet because we can't get a change of base just yet. Because you can't change 14 into a base 2. So we'll learn that in just a minute. Alright, so what if our x is in different spots? What if our x is not like it is here? I'm not asking you a straight up log problem. For example, it says log of what base of 25 is 2. So now it's saying what number squared is going to give me 25. What number squared is 25? Well, how do you know that? Because remember your base, you're going to change it to exponential. You have your base, which is x here. Your base is x, raised to the 2nd power is equal to 25. So from here, you know the answer to this. Take the square root of both sides if you want to. And so x is equal to plus or minus 5, but you can't have a negative, so x is technically just equal to 5. Can't have a negative base. So again, it's just manipulating, rewriting log as a exponential. Okay, so for b, same thing. Your base is going to be 25. 25 to the 3/2 power is equal to x. So it's saying 25 to the 3/2 power is going to give me what number? And that's how you would read that log. So how would you go about solving this? What do you think? Watch this. Same thing that we were talking about here. You know how we went from radical to exponential? Let's go from exponential to radical and see what happens. That 2 on the denominator tells me I'm taking the square root of 25, and then that 3 tells me that I'm going to cube it. Well, what is the square root of square root of 25? Square root of 25 is 5, and 5 cubed is what? So x is 125. So 25 to the 3/2 power is going to give me 125. So again, you do need to learn, do need to know how to manipulate these to get what you want. That's the hardest part about these, learning how to manipulate them to get what you want. All right, so number 7 you should be able to do. Number 6 you should be able to do. Um, 17, not yet. Close, but not quite. All right, so let's look at these properties. To get to these properties, 1 through 4 comes straight off of what we've already talked about. Log of base to the 1 power is equal to 0. Basically, it's saying anything to the 0 power is 1. You already know that. Anything to the 0 power is 1, because if you change this to exponential, b to the 0 power, anything to the 0 power is 1. And then for number 2, anything to the first power is itself. These are all properties that you're going to mix in to solve these equations. For number 3, any base, if we rewrite it, that's obvious, right? So this is a good one to use. The bases, if the base and the base and what you're taking the log of is the same, they'll cancel each other out. Same thing for number 4, that's going from exponential. The base of a log with the same base cancels out, and you just get x is equal to x. Now, 5, 6, and 7 are new, but it goes hand in hand because, remember, if you can think of logs as exponentials, then these properties should make sense to you, because if you multiply powers with like bases, so for example, x to the 3rd power times x to the 4th power is x to the what? 7th power. When you multiply powers with like bases, you add those exponents. You add those exponents. So, look at this, number 5. If you have the log of any base of a product, the log of any base of a product, m times n, what you can do is you can separate that into 2 separate logs, which allow you to put this in your calculator. Log of any base of m plus the log of base of the same base of n. And that goes hand in hand with what we did here. When you multiply powers with like bases, you add the exponents. So when you take the log of a product, you can split it up into an addition problem. Just like if I had something like x to the 7th power divided by x to the 3rd power. When you divide powers with like bases, what do you do with the exponents? You subtract them. So you get x to the 4th power. Remember this from Math 100? Same thing here. Log of any base of a quotient. Log of any base of a quotient. You can separate that into a subtraction problem. And it's the exact same rule as here. Okay, number 7. When you have, and look how I'm reading this, okay? When you have the log of a base of an exponent of a power, okay? Log of any base of a power. What you're going to do is you're going to take this power and you're going to move it as a coefficient. So that power of your argument is going to turn into the coefficient. So now you can write this as r times log base b of p. The only thing that changed is you're moving your power of your argument down as a coefficient. And that gets rid of your exponents, basically, in a log, because you don't want your arguments to be an exponent. You don't want your arguments to be an exponent. Okay? And that's an easy case. So remember these rules. 1 through 4, if you don't remember them, it's not going to be hazardous because you can put it in your calculator. 5, 6, and 7, however, you've got to know. You can't do that in your calculator. Okay? All right, so let's try this. Evaluate each logarithmic expression. Again, you can put the x there if you need to. So if we say 5 to the what power is equal to 1? There's no way to change 5 and 1 to be the same base. There's no way to do that. But anything to the what power is 1, 0. And if you will remember rule number 1, that tells it to you. If your argument is 1, your answer is 0. If your argument, now you understand what I'm calling the arguments, right? What we're taking the log of. If your argument is 1, your answer is 0. Okay, look at this one. What did I tell you if your base and your argument were the same? If your base and your argument are the same, your answer is going to be 1. Your answer is going to be 1. If your argument and the base are the same, it's going to, and again, you can change this to the exponential 4 to the what power is going to give you itself. The only power is 1. Anything to the first power is itself. Okay, what if your log is in the power and the base of your exponent is the same as the base of your log? The base of your exponent is the same as the base of your log. What did I tell you? Yeah. They are going to cancel out here, and you're going to get your argument of your exponent. You're going to get the argument of your exponent, which is going to be 14. Okay, so for this one, this time you have your base and your argument look the same, but not necessarily. So let's change this one to exponential. We're going to have 7 to the what power is going to give you 7 to the 1/2. Look. So you're going to get x is equal to 1/2. All right, so again, it does come in handy to remember those rules. So let's go here. If you see something that it says to expand each logarithmic expression, so for example, number 8. Number 8 says express log base b of that huge argument as the sum or difference of a simpler logarithmic logarithmic quantities. Basically, what I'm asking you to do is I'm asking you to turn that into something that you can put in your calculator fairly easily. Okay, so expand each logarithmic expression. Expand it or write it in simpler terms. In other words, we don't want a product here. So how do we change a product? What is the product going to come into? What is the product going to go to? Addition, right? All right, so for this one, we're going to have log base a of x cubed plus log base a of y plus log base a of z to the 4th. So let's see how many of you are listening. Is this the correct answer? Yes or no? Why? Very good. You cannot have exponents in your argument. We do not want exponents in our argument. Do you remember what to do with them? Pull them around as a coefficient. So this is going to turn into 3 log base a of x. There's not a power here aside from 1, so we'll just leave it as is. And then this one's going to turn into 4 log a of z. And so now that looks a little bit easier. So for number 8, when it says express this logarithm as the sum or difference of simpler logarithmic quantities, this is what you're doing. You're using properties 5, 6, and 7 that are on the previous slide. Okay, so let's look at the next one. We're going to have log base b of 4 plus log base b of w minus, do you understand why minus? You have the quotient. Okay, so minus log base b of v squared. And if you want to go ahead and move the 2 around front instead of making a whole nother problem, that's fine. Alright, so the last one, we'll have log base b of m squared plus log base b of n to the 1/2, right? Square root is the same as to the 1/2 power. Power over index. And then let's move these exponents out front. And so that's how you should be able to do that one. Okay, so number 8. You want to try it? Try number 8 on your test and see what happens. Okay, so you know, look at this. It says express as a single logarithm. You know that your coefficients are going to become powers of your arguments, right? So this is going to turn into log base x a squared minus log base x b cubed. And then that subtraction sign in between there tells you to do what? Yeah. So you're going to have log base x of, and of course the first one's going to go on top and the second one's going to go on bottom. Okay. So the next one we'll have log base x of x minus log base x of y to the 6th minus log base x of z cubed. So now, oh, that's a plus. So now we have log base x of x. Minus sign tells me that I am dividing y to the 6th. And then that z to the 3rd, where do you think it's going to go? Top or bottom? Yep. Very good. So you're going to have log base x as a single log, and then you have x. The plus sign goes to the z to the 3rd, so that's going to be multiplied by, and then over y to the 6th. Now watch, don't get lost on this. So if we write this, you're going to have x, and you know that that division sign is y to the 6th, and then that addition sign says we're going to multiply z to the 3rd. Right? Addition goes to multiplication. And then when you multiply fractions, of course, the tops. So that's why the z to the 3rd goes on top. So don't get lost on that. Alright, so now you should be able to do number 4 rather easily. That one's actually easier than the one we just did. Okay, so solving equations. This is where rubber meets the road. Solve equations with sums and products of logarithms. You must use the properties that we just talked about. Okay, so here are 2 examples. If I have log base 10 of x is equal to log base 10 of x minus 3 is equal to 1. So in order to do this, in order to solve an equation, I need 1 log, not 2, I need 1. So what I need to do is I need to consolidate this. I need to express this as a single log. That plus sign tells me it's going to be what? Right, so we're going to have log base 10 of x times x minus 3. So you consolidate the log into 1 log, so you have log base 10, and then you make a product of your arguments. You're just going to multiply your arguments. Now, if you want to go ahead and use the distributive property, you can. And then this is going to be equal to the first power, or equal to 1, which is going to turn into your power because your next step, once you get it written as a single log, once you have it broken down into 1 log, your next step is to change it to exponential. Your next step would be to change it to exponential. So you're going to have 10 to the first power is equal to, and I'm going to go ahead and distribute that product, so we're going to have x squared minus 3x. So you see what I did? I changed my log to exponential. Very first thing we learned how to do today. Actually, the second thing. But anyway. Alright, so 10 to the first power is just 10, right? That's no big deal. But we see that we have a quadratic. And anytime you have a quadratic, what do you want to do? If you're solving a quadratic, what's the first thing you always need to do? Yeah, get it set equal to 0. So I'm going to minus 10 from both sides. So I'm going to have 0 is equal to x squared minus 3x minus 10. And we've already talked about this semester. You know how to solve a quadratic. You have one of two options. You can either factor it or you can use your quadratic formula. That's completely and totally up to you. If it will factor, I prefer to factor, and this one will, so that's the way I'm going to go. If you don't like factoring or you don't know how to factor, use the quadratic formula. So this is going to be x minus 5 and x plus 2. And then take each one of these and set them equal to 0. So we have x minus 5 is equal to 0. And you have x plus 2 is equal to 0. And so we'll get x is equal to 5 and x is equal to negative 2. Word of caution, and you need to write this down. Make sure you understand this for your test. You cannot take the log of a negative number. You cannot take the log of a negative number. Now, having said that, your argument cannot be negative. Okay? Having said that, when you solve these equations and you come up with a negative number, don't automatically just throw it out. Do not automatically just throw it out. Because watch, if I plug, or even your positive numbers, your positive number may not work. Because if you take 5 and you plug it in here, your argument becomes 5. That's okay. That's good. We don't have a negative number. If I take 5 and I plug it in here, 5 minus 3 is going to be 2. That's good. I'm taking the log of a positive number. My argument's positive. So 5 is going to work in both situations. So 5 is an answer. If I take this negative 2 and I plug it in here, my argument is negative. So that negative 2 will not work. But, word of caution, that's not always going to happen. Sometimes you can come up with x is equal to a positive number and you plug it back into your argument for your variable and you come up with a negative number, which means there's no solution. Take your numbers that you get x equal to. Take your numbers that you get x equal to. Plug them into your arguments. Every one of your arguments, plug them in. As long as you're coming up with positive arguments, once you simplify, that's fine. But if you ever come up with a negative, mark it off. Your argument cannot be negative. Okay? So let's look at the one on the right. This one always trips up my pre-cal students, which is not, it is comical, but it's not comical. Let's see if we can figure this one out. You're going to have log base 10 of that subtraction sign. Tells me that I'm going to turn my 2 logs into the log of a quotient, right? That subtraction sign tells me I'm going to turn it into the log of a quotient. So, we're going to have 2x minus 1 over x minus 2 is equal to that 1. So now that I've got 1 log, that's your first step. Your first step is trying to get it down to 1 log. What was your second step? Exponential. So we're going to go 10 to the first power. Of course, we know that's going to be 10. Is equal to 2x minus 1 over x minus 2. And my pre-cal and my calculus students even, they look at this and they're like, I don't know what to do with that. Yes, you do. Yes, you do. What do you think? What are you looking at? What do you have when you have 2 fractions set equal to each other? What is that called? Starts with a P. R. Proportion. Okay? Yeah, you just cross multiply and solve. Now, don't you think, oh my gosh, I knew that. Yes, you knew that. You just forgot. So, you're just going to cross multiply. Alright, so we'll have 10x minus 20 is equal to 2x minus 1. And then from here, of course, this is a linear equation. You can solve this. So we'll minus 2x from both sides. And so we'll have 8x minus 20 is equal to negative 1. Add 20 to both sides. 8x is equal to 19, divide by 8, and you're going to get x is equal, and you can leave it as 19/8, or you can turn it into 2 and, 3/8, whatever. And the reason I say that, it doesn't matter to me how you give me the answer. I prefer not a decimal, but if you give it to me as a decimal, that's fine, because it could possibly be no solution, right? Why? You have one more thing to do. Don't say, okay, x is equal to 19/8. I'm done. You've got to plug it back in. You've got to plug it back in. So, and you can do this in your calculator if you need to, but 2 times 19 over 8 minus 1. What do you think? 2 times 19 over 8 minus 1. Are you going to get, the biggest question is, are you going to get a positive or a negative answer? You're going to get a positive answer. So we're good for that one. So let's take 19/8 and put it in for the next one. 19/8 minus 2. 19/8 minus 2. Are you going to get a positive or a negative answer? You're going to get a positive answer. That's what matters. Okay? And so, yes, 19 over 8 is a solution. Make sure you check these. Make sure you check them. Okay, so let's try again. We're going to change these to 1 log. You see the plus sign in between, so that tells me that I'm going to multiply my arguments. Right? Multiply those arguments because of the plus sign. That plus sign tells me to multiply the arguments. So 5 times x is 5x, and of course it's equal to 1. Next step, change it to exponential, so we'll have 7 to the first power is equal to 5x, and of course 7 to the first power is just 7. And then to solve for x, you're just going to divide by 5. And so we get x is equal to 7/5, or 1 2/5, however you want to do it. Okay, so log base 7 of 5, we can do that in our calculator, but this is where it matters. Here's your variable, log base 7 of 7/5. Is our argument positive or negative? If you plug 7/5 straight in, is your argument going to be positive or negative? It's going to be positive. So this answer is good. It is good. Okay, let's go here. What's different for this problem versus the 3 problems we've done previously? Your base, yes, but what else? You have logs on both sides. You have logs on both sides. Well, if you use your algebra technique, think about solving algebraic equations. If you use your algebra technique, if you have variables on both sides, how are you going to fix it? Yeah. So I would add log base 2 of x plus 3 to both sides. So I guess my question would be is, can I add these two together? And get what? What would you get? I'm going to write it like this. Let's see if that'll help you. And I say yes that you can add these together because technically you're not adding them together. The arguments are not the same. So no, you can't add them. You can't add your arguments. You can't do anything with your arguments, okay? The only way that you would be able to add your arguments, well, you can't add the arguments. In other words, the only way that you could put these together is if you had log base 2 of x plus 2 and log base 2 of x plus 2. If they look exactly the same, then you would have 2 log base 2 of x plus 2. Do you see what I'm saying? If you had the exact same thing, think of variables. They have to be like before you can put them together. So, right, I can't put these together because the arguments are not the same, but I can consolidate them into one, and that's what I was hoping you were saying when you said yes. So we're going to multiply those arguments, actually. Okay? So the plus sign in between tells me to multiply the arguments. Let's go ahead and change this to exponential. We're going to have 2 to the first power. Of course, it's going to be 2. And I'm going to go ahead and pull this out. So we're going to have x squared plus 5x plus 6. I see that it's a quadratic. Right? So we need to get it set equal to 0. So we'll minus 2 from both sides. And so we'll have 0 is equal to x squared plus 5x plus 4. This one will factor. And so we're going to get x is equal to -4 and x is equal to -1. Therefore, no solution, right? Right. X minus 4 and x -1, or x is equal to -4 and -1. They could be solutions. Okay, so what about -4? -4 is not a solution because if I put -4 in here, -4 plus 2 is -2, your argument cannot be negative. If I put it in here, -4 plus 3 is going to be -1, your argument cannot be negative. So this is not a solution. But don't mark off -1 just yet. Remember I told you that was the word of caution that I told you. Just because you come up with a negative number doesn't mean that it's not a solution. You got to plug it back in here because that's what matters. -1 plus 2 is +1. That's good. And -1 plus 3 is +2. That's good. So this is a solution. So just be careful with that. On the back side of your test, you should be able to do 10. I think you can do 18. We haven't talked about natural logs, but for number 19, I think you can do that as well.
Does it make any difference between log and the LA?
It makes a difference of inputting it in your calculator. It's different exponentials. But as far as the process, no. Okay, so let's talk about base 10. In your calculator, if you have the appropriate calculator, if you have inappropriate calculators, you can do things that are aside from base 10, and that's why I don't allow graphing calculators and I don't allow that engineering calculator either. So, which is the collaborative test on, you can use whatever you want. But if you do not see a base, it's understood to be base 10. And that's the one that your calculator will do. Find your LOG button on your calculator. Every scientific calculator has an LOG. So find that LOG on your calculator. The LOG on your calculator, the logarithm on your calculator is a base 10. And it's only a base 10. So if you see something like this, base 2, your calculator will not do it. You have to use other means. You have to change it to exponential or something else to do it. But if you don't see a base, it's understood to be base 10. This you can put straight into your calculator. So in your calculator, do log of 1256. Log of 1256. And we're going to round to 4 decimal places. And it depends on your calculator how you're going to do this. But either way, you should come up with 1.099, and if you want to tag the 0 in just because it says 10 thousandths, that's fine. Alright, so try all of these. Make sure you can do this in your calculator. And if you've got it, you know that you've got it in your calculator, find the one on the test that matches. So this one's going to be -2.87. No, I'm not looking at that right. -2.8697. of you will have to type the number in first. Are y'all discovering that? If you have a single pane calculator, in other words, it doesn't show you what you're typing, you just have to, then you're going to have to type in the number first. For those of you who have a double pane, then you can type it in just how you see it. Anybody need help with their calculator? Alright, so like number 12, you could do number 12. Okay, so what if you don't know the argument? What if you're looking for the argument? Anytime you're looking for the argument, you have to change it to exponential. You have to use the inverse. Okay? Anytime you go from log to exponential, you are doing the inverse. So you're going to do 10 to the 3.625 is equal to what? 10 to the 3.625. On your calculator, find your log button and look right above it. Not the button above it, but the painted thing above it on your calculator. You see where it says 10 to the x power? That's your inverse of log. That's where you're going to use this. So, this time you're going to hit your shift or second button, whatever your case may be, and then hit log, and it should bring up a 10, base 10 for you. And then you'll type in your number, 3.625. And I'm coming up with x is equal to 4,216.97. Is that what y'all got? Some of you may have to type in 3.625 and then. No, you should be able to do it. You're just going to hit the blue button.
I got that.
So everybody can do this in their calculator, hopefully. Again, if you don't know the argument, change it to exponential. So we'll just run through these, make sure you can come up with the same numbers that I'm coming up with. Alright, so anybody need help with their calculator? Doing the inverse. Negative 1.976?
Yeah, I got 94.62.
Okay, so now let's talk about that natural log. So how do we go from log to natural log, and do they mean the same thing? No. Natural log means we're taking the log of a base e. Do you remember what e is? E is a constant. It is a constant, and yes, funny that you know that, but yes, that's awesome. Not funny. But it is a constant, and we learned that when we were doing the PERT formula, remember? Okay, and so the nice thing is it has an E button on your calculator. We've already learned how to use the E button on your calculator. So anytime you take the log of base E, basically what you're doing is you're taking the natural log of an argument, the natural log of an argument. So in your calculator, again, if I'm just asking you to take the natural log of an argument, instead of using the LOG button, you're going to use the LN button. And so for my calculator, I hit LN and then the number of 3.52, and I come up with 1.2585. So again, this one's not so bad. Just make sure you know how to get them in your calculator. And make sure your rounding is correct. Alright, so your natural log, and then of course your inverse of your natural log is your e to the x, which you already know how to use. But just to refresh, look, if you don't know the argument, you have to turn it into base e. You have to turn it into exponential. No. So you're going to do e to the negative 0.349 is equal to what number? So that's how you're going to find your argument. You're going to turn it into exponential. So again, for my calculator, I'm going to hit the shift button, LN, which takes me to the e to the x. You've already had practice working on this. And then hit negative 0.349. And I'm coming up for my argument is going to be our x is equal to 0.7054. Is that what y'all got? Yes, no, maybe? Katrina, is that what you got? Oh, sorry. Beth? Okay. What kind of calculator do you have, Beth? Is it the one that I like or the one that you like? Uh-oh. I don't have one like yours, do I? If I do, I'll go get it. Okay. Okay, good. Alright, so again, you already know how to use your E button on your calculator, but again, if you're looking for the argument, anytime you're looking for the argument, whether you're doing natural log or logarithms, just remember you have to change it to exponential form first. Alright? Guys, y'all can't come in late. Go on. Alright, so exponential and logarithmic equations. We've already talked about this a little bit, so now what are we going to do? Well, if x is greater than 0 and y is greater than 0 and b is not equal to 1, just wrap your head around that, then x equals y if and only if your log base of any base of x is equal to the log of any base of y. So this is how we're going to use this little property, and it'll make more sense to you when we use it, actually. Basically, it's just saying that your arguments are going to be equal to each other. Alright, so look. If I have 5 to the x power is equal to 14, and you go back to what we were talking about in 10.1. Typically, if you see a problem like this, you would change it to the same base, right? Remember what we did last week? You would try to change it to the same base. But for 5 and 14, you can't change these to the same base. There's no way to get 5 and 14 to be the same base. So what are you going to do? You're going to take the log of both sides. In order to solve an equation like this, in order to solve an equation that you cannot get to be the same base, you're going to take the log of both sides. Because remember, when you do something to one side of an equation, you've got to do the same thing to the other side. So if I take log of 5 to the x is equal to log of 14. As long as I do the exact same thing to both sides of the equation, I've really done nothing. It's still balanced. It's still balanced. Okay, so now, you can't take the log of an exponential. Your arguments cannot be exponential, so what do? There you go. So you're going to have x times, and that's what you're doing, x times log 5 is equal to log 14. How would you get x by itself? Yeah. Divide by log 5. Do you know how to find the log of 14? Do you know how to find the log of 14? You're handy dandy calculator. We just learned how to do this, okay? Log 14 divided by log 5. Word of caution, use parentheses. Use parentheses. Log 14 is going to be your numerator. And depending on your calculator, just be careful with those parentheses. So we're going to have log 14 divided by log 5. And so you get x is equal to 1.6, I'm just going to round to 2 decimal places, 1.64. Now you should be able to do number 20. Now you should be able to do number 20. Number 17 as well. Once you get number 20 set up in exponential, it's going to look just like number 17. Just like number 17. So 17 and number 20, you're going to work the same way. It's just number 20, you have one more step to do. Okay, so let's keep going. Look at this one. There's no way that I can change 3 and 31 to be the same base. No way whatsoever. So I'm going to take the log of both sides. Better read off it. Okay, I don't want my exponential there, so I'm going to do x plus 2 times log of 3. Why did I put plus there? That should be equals. Jiminy crickets. Can you tell I'm worried about the weather as well? I'm trying to get y'all out of here and home before the weather hits. Alright, so you have x plus 2 times the log of 3 is equal to the log of 31. Now I need that group of x plus 2 by itself, so you're going to do the exact same thing. We're going to divide both sides by log 3. And so you're going to have x plus 2 is equal to log 31 over log 3. Now, just because I'm familiar with my calculator, I prefer to go ahead and get x by itself before I start putting anything in the calculator because you're dealing with decimals, and I don't want you rounding any decimals because it's going to throw your answer off. So to get x by itself, I'm going to minus 2 from both sides. So basically, I'm going to have x equals log 31 divided by log 3 minus 2. And I'm going to put all of that in my. So again, just because of the way I prefer to work my calculator, I just like to get everything on one side and then put it all in my calculator. So I just did parentheses log 31 divided by parentheses log 3 minus 2. So I put my numerator in parentheses, I put my denominator in parentheses, and then hit equals. If you have a single pane window, it's going to be a little bit more difficult, but you're just going to have to fight through it and figure your own calculator out. Okay, for this one, I need my power by itself. So right off the bat, I'm going to minus 1 from both sides. Okay, you need your power by itself, so we're going to get 4 to the x power is equal to 52, minus 1 from both sides right off the bat. And then you're back to the problem that we had right above it, so you're just going to take the log of both sides. Get your argument out of exponential, so you're going to have x log 4 is equal to log 52. And you know what to do from here. So you're going to have log 52 divided by log 4. And this is the long way around. I will agree with you on that. Well, some of you. So if you know the shortcut, take it.
One thing, just one that I was the x that you cut into the on that is the long way of watching. This last thought. 413 times is 52.
No.
So just got it.
4 to the 13th power is some huge gigantic number. Just remember you're dealing with exponents, not multiplication. Alright, so x is equal to 2.85. Okay, you see the e there. So now, since you see e, are you dealing with LOG or LN? You're dealing with LN, okay? When you see e in your problem, you're dealing with natural logs instead of LOGs, alright? So what we're going to do this time is we're going to take the natural log of both sides. And I want you to do a little experiment for me. And it's one of your properties. The natural log is base e, right? Natural log of e is the same as log base e. So in your calculator, do natural log e. Natural log e. What do you get? If you know your properties, you should already know the answer. What do you get? Should be getting 1. You take my natural log of the inverse. So it's 1. They're going to cancel each other out. So when I move that x out, ln of e, put that in your calculator if you need to, but that's going to go to 1. So now x is equal to the natural log of 42, which is some decimal. And you get 3.74. Is that what you came up with? So again, just remember, anytime you see that e, you're going from LOG to LN. Okay. Yeah, because I don't know how to write the problem down correctly. It is 43. I know that's sad, isn't it? That's because you and I think alike. We're just trying to, yeah, you know. Read my mind right now. Okay, so natural log of 43 is 3.76. So, if you can do change of base like we did in 10.1, do change of base. If you cannot do change of base, then depending on which one you're dealing with, you're either going to take the LOG of both sides or the LN of both sides. Alright? So again, now you should be able to do those. Number 16. Let's talk about that one for just a minute. I'm going to leave Tegrity running so that those that are listening at home can hear this. If I asked you to do number 16, What do you think that you would do? It's pure calculator work. It's pure calculator work. That's asking you to do 2 times the natural log of 9 divided by the natural log of 5. However, you got to get it in your calculator correctly. Okay? You've got to get that in your calculator correctly. 2 times the natural log of 9 divided by the natural log of 5. And I'm not going to tell you the answer, so y'all can discuss that amongst yourselves. I'm not going to give you the answers to your test. But that problem, for some reason or another, throws everybody off when it's an easy problem. Totally easy problem. Okay, this one. Watch this. If you have 7 to the what power is equal to 21, and there's a shortcut to this, and you'll pick it up as we go along doing this, okay? Change it to exponential, and you notice you cannot change 7 and 21 to like bases. If you could, that's the way that you would go. But instead, what we're going to do is we're going to take the log of both sides and pull our exponential out front. Well, we need to take the log of both sides, Dana. Alright, and so we're going to have x is equal to log 21 over log 7. Do you see a shortcut? Going straight back up here. Well, going straight back up here. Log base 7 of 21 to here. From here to here. Yeah. And this works every single time. Every single time. Okay? Just going from here to here. So if you see the setup and you notice that you can't change your base, or even if you can change your base, you can still do this. It doesn't matter. Alright, so this one. I won't do the shortcut. So we have 3 to the x power is equal to 41. So we're going to have x log 3 is equal to log 41. And so you'll have x is equal to log 41 over log 3. So again, just compare this problem, what it's asking for, to our setup. And every time it works the same way. So when you see this, just know it's the log of your argument divided by the log of your base. The log of your argument divided by the log of your base. Every single time. Alright, so number 20 you can do rather easily. Alright, let's go back to the equations. I'm not really sure why I did this, but we will anyway. Okay. Do you remember how to work this? This one on the left, what are we going to do? Yeah, you're going to multiply your arguments. We're in base 10. Maybe that's why I did it, but still. So we're going to have log of x times x plus 3. We've already worked one just like this. Change it to exponential, so you have 10 to the first power is equal to x squared plus 3x. Since you have a quadratic, set it equal to 0. This one will factor. And so we'll get x is equal to negative 5 and x is equal to 2. So I can automatically mark that negative 5 off. Yes or no?
Yeah.
Not automatically, but yes, you can, because, yeah, when you plug it back in, it is going to go to a negative argument. So yes, we can. And the 2, is it good or bad? It's good. So that one's good. All right, the one on the bottom. That minus sign tells me to what? Divide, so we're going to have x over x minus 2 is equal to 2. Now this one, we haven't seen one like this, but watch this. This is the big difference. Nothing miraculous. Your base is 10, so you're going to have 10 squared, right? 10 to the second power is equal to x over x minus 2. So from here, you're going to have 10 squared is going to be 100 is equal to x over x minus 2. Do you see where that came from? Going from exponential, your base is 10. I know that because I don't see a base. And going from log to exponential, it's base to the second power is equal to your argument. Okay? From here, what do? Cross multiply. So you're going to have 100x minus 200 is equal to x. It's not quadratic this time, so I don't have to get it set equal to 0. So I'm just going to, it's just linear. So we'll minus 100 from both sides. So we have negative 200 is equal to what? Negative 99? Weird. Divide by negative 99. That is a 9. And so you have x is equal to 200 over 99. Put that in your calculator, or if you need to. If you plug it in here, of course it's okay, but 200 over 99 minus 2. Good or bad? 200 over 99 is going to be 2 point something something, right? So 2 point something something minus 2 is going to give you a positive point something something, so it's good. It is good. Natural log. Haven't dealt with this yet. Look at this. Look. I love this problem. What do you notice? Your natural log is in every single term. Your natural log, the fact that it's a natural log or an LOG has no bearing on it whatsoever. The biggie is that it's in every single term. It's in every single term. I'm going to go ahead and make this into one natural log on the right-hand side to help you see this. That's going to turn into multiplication, so my argument's going to be 3 times x minus 4. You remember a while ago when I told you that if you take the log of both sides, you're not really doing anything. Same thing here. If I have the natural log on both sides, I'm not really doing anything. So guess what? Drop them. So now you have x plus 2 is equal to 3x minus 12. And you have an equation that you can solve. So look for that. If you have the LOG or the natural log in every single term, drop them. You don't need them. All right, so let's minus x from both sides. Add 12 to both sides. And so you get x is equal to what? Yep. Very good. And is 7 doable? Yeah. Absolutely. All right, this one, I think we've already done something like this. So what are you going to do first? All right, so we're going to add log of x plus 3 to both sides. All right, and since we're adding, your argument's going to turn into what? Multiplication. So we're going to have x minus 2 times x plus 3 is equal to 1. All right, so we're going to have 10 to the first power is equal to that. X squared plus x minus 6. Just pull it out. Minus 10 from both sides because we have a quadratic. And so we have 0 is equal to x squared plus x minus 16. This one is not going to factor. Pretty. What do? Panic? Quadratic formula. X equals, opposite of b is going to be negative 1 plus or minus the square root of b squared minus 4 times a times c. All over 2 times a. Did I get it set up right? Check my math. Okay. All right, so we have x is equal to negative 1 plus or minus the square root of 65 over 2. How many answers do I have? 2 possible answers, right? I have 2 possible answers. In order to check this, you're going to need decimals. Okay, so let's see if we can come up with decimals in our calculator. What I want you to do is I want you to do 1 plus the square root of 65 divided by 2. In your calculator, 1 plus the square root of 65 divided by 2. And you can round it. What did you come up with?
I'm not sure I put it in right, so I got 5.06.
That's not what I came up with. Anybody? Maybe I need to try it again. Oh, it's -1. Maybe you are right. Let's try. I didn't put in the -1. Maybe I didn't put it in right. So you have -1 plus the square root of 65 divided by 2. I came up with 3.53. Okay. 53?
Why am I putting this in the ball?
I don't know. -1. Try this one with me, Nick. Yeah. You gotta do the whole numerator, hit equals, and then divide by 2. Otherwise, you're just dividing the square root of 65 by 2. So make sure you put the whole numerator in. Yeah, that's it. Alright, so this time we have -1 minus the square root of 65 equals divided by 2. Not 3, divided by 2. And that time I came up with -4.53. Alright, so let's test these. If I plug in 3.53 here, is that good? Yes, and if I plug in 3.53 here? Good. Alright, so this one's good. -4.53 here? No. -4.53 here? No. This one's bad. So 3.53.